Good afternoon, class. We are looking at the final exam review covering section 1.625.4. We've done a big chunk of that, looking at differentiation, formulas, delta y versus dy, linearization, in essence, is finding the tangent line, logarithmic properties. If we could figure out how to go from logarithmic format using this arrow to exponential format, all properties are easy to understand. Basic integration formulas, which is the reverse process. We are adding the FTC, the substitution rule, differentiation using the chain rule, implicit differentiation, sinusoidal functions and their derivatives, related rates. It's important whenever we deal with word problems to have a drawing defining our variables and moving on. Related rates in this case, of course, uses implicit differentiation. And other related rates, I hope you realize the importance of having defined our variables and the diagram. We have to draw the, drawing to help us see what the variables are. When we want to find the limits, in short, plug in and observe. Rational expression, try to simplify, meaning if you can, factor and put them in lowest term before you move on. Exponential format, how we deal with them when we want to find the limits. All of these cases end up being 0 over 0. The first one requires factoring. The second one is a complex fraction. LCD will do the job, and the last one, conjugate, will do the job. Differentiating logs, it's important to simplify them first and foremost. Meaning, if we can, we decompose the log and then we move on. In this case, on this page, I wanted you to see the differentiation versus integration versus initial value problem. So all of them on the same page to serve that purpose. When you integrate and ln x is involved, that is normally the choice of you, as it's the case here. Anytime we can divide and simplify, we must, as it is the case here, whether we are differentiating or integrating, the first step of dividing and making up two fractions is the same. And finally, on this page, we looked at first A and B that are fractional expression. The first one is a fractional expression. The second one is a rational expression. And when we cannot simplify the denominator, is a choice of you. And part C is the reciprocal of part A to show you we don't have to use the substitution method all the time. What happens in this case, again, ln x is involved. So that is the choice of you. You know the derivative of ln x is 1 over x, therefore du is 1 over x dx, or dx over x. We want to write this in a format so the components become clear. This is ln x to the power of 2 and 1 over x dx. So this is u squared. This is du. The power rule will give us 1/3 u cubed plus a constant. The u is replaced with natural log. And make sure you keep it in a parenthesis, because if you don't have a parenthesis, it has a different meaning. Part B is a fractional expression. The question is, can be simplified further? The answer is no. Notice the derivative of e to the power of x is e to the power of x. The derivative of e to the power minus x is minus e to the power minus x. So the derivative of the bottom is the top. So if you choose this one to be u, this one times dx becomes du. Therefore, we're going to put the du at top. And now we are dealing with the integral of du over u, which is the natural log and a constant, and u will be replaced. If you change the absolute value sign to parentheses, it works because this expression is positive. I want to go over this word problem. Anybody feels like reading the first part all the way to the end of part A for us?
I can read it.
Please.
A doctor prescribes a 300 milligram drug to be taken every 12 hours. Just before each tablet is taken, 40% of the previous amount of drug remains in the body. Write the expression for Qn plus 1 in terms of Qn.
Perfect. Now, we have the formulas and everything. It's important when you do word problems, you dissect the problem and write the given. So first and foremost, because it says Q here, when I look at this formula, I'm going to change the B to Q. That's important to know that. So I want to write the given before I start part A. So 300 milligrams, this is a constant, lowercase c. Constantly, we are adding this much. Every 12 hours, this is a very important number that has been calculated, but it's got nothing to do with these formulas. For example, the weight of the patient has an effect on that. So it's important to know you can even change it in your mind, 12 hours every 20 hours every week. You see that it doesn't have any effect for those formulas. What remains in the body is the ratio or the percentage. So R is 0.4. And of course, the initial value, B sub 0 or A, we're going to call it A or Q sub 0. That is 0 always when it comes to medication and patients. Now, I want to discuss this 40% again. This is the amount that remains in the body, the percentage of medication that remains in the body, which means if this is 80% of the previous amount is absorbed, that means 20% is left. So what is left in the body is the value of R. Now, I'm going to write this formula with Q. Look at this formula. We change the B to Q. And all you have to do, this is the beauty of writing the given. I'm going to replace the R with 0.4, lowercase c with 300, and we are done. For this one, to find Q sub n, I see the formula here. So I'm going to change the B in this formula to Q. So it's the same formula. I'm changing B to Q. Now I use the given. Q sub 0 is 0. R is 0.4. Lowercase c is 300. And zero times any number is 0. This is 0.6. If I divide 300 by that, it's the same as 3,000 being divided by 6, leaving us 500. How much drug is left after the 5th tablet. If you recall when we did in the beginning, so right here, they would have asked us, we would make up a table 1, 2, 3, and we come up with this answer. Since we have come this far, all we have to do, replace the n with number 5. So 500 times 1 minus 0.4 to the power of 5. We calculate this, we multiply it by 500, and we write the units, always units, 494.88 milligrams after the fifth one. And finally, what is the limiting value? That means take the limit of this expression. As you recall, when you take the limit, since this number 0.4 is between -1 and 1, as n goes to infinity, this goes to 0. Therefore, 500 times 1 minus 0. So this goes to 0. As n goes to infinity, the answer is 500 milligrams, meaning in a long run, no matter how many times you repeat this, every 12 hours forever, it will never go beyond 500 milligrams, which they have calculated to be safe for the patient. Could somebody read this question for us, please? Okay, no one? Many fish grow in a way that is described by von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter and has a maximum length of 30 centimeters, this equation predicts the growth rate is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will the fish be after 4 years? And we want to round it to 1 decimal. So if capital L of x represents the length of a fish at age x, then the growth rate is the derivative of that function. L prime or dl dx is 29 e to the power minus x with the proper unit, centimeters per year. So the amount of increase follows the accumulated change or net change theorem, and it is the integral of that over the course of 4 years from 0 to 4. Now, as you know, the integral of this, we divide by -1, we get -29 e to the power minus x, evaluated from 0 to 4. So plug in 4, plug in 0, it's easier to keep the -29 out. Obviously, this is 1. And you have to use a calculator. E to the power minus 4 minus 1 times -29 results in this number. And initially, the length is 1 centimeter. We need to add these two numbers. And since it says 1 decimal, look at number 4. Next to it is 6. We take it up and we make it 20.9.5 proper units, centimeters. The second method that has been always discussed, instead of finding the amount of increase, we find the equation for capital L of x. So this is the answer. We add a constant with the initial value of 1. So 1 equals, if I replace the x with 0, obviously, this is 1. So -29 plus c equals 1. Therefore, c must be 30. And all we have to do, plug in 4 here. The advantage of this equation is that if we have several parts, after 4 years, after 10 years, after 20 years, we can plug in and come up with it. 29.4688. As you see, is the same as this one, and of course, one decimal will result in 29.5 centimeters. We want to integrate these two, and the idea is that we are dealing with rational expressions. And even if we can factor this, it makes no difference, because if we want to simplify this, we need a factor of 4x plus 1. Since this is 4, we can't make it happen. So let u be the denominator, which is 2x squared plus x minus 3. And du is 4x plus 1 times dx. Now, if I put the dx at top, I'm dealing with the integral of du over u, which is a natural log and a constant. And I can replace the u, and I'm done, and I must keep the absolute value sign because the expression can be positive or negative. In part B, I noticed the numerator can be factored into 4 times x minus 1. Then I try to factor the denominator, and we do have the same factor, namely x minus 1. And now we are going to use the u substitution. We let u be 2x plus 3. Du is 2 dx. And if we put the dx at top, we have 4 dx. We need 2 dx. So 4 dx is 2 times 2 dx, not a big deal. Because of that, I'm going to cut the 4 into 2 pieces, 2 times 2. So notice I need 2 dx, and I have it at top, and this number 4 is not going to go anywhere. 2 times 2 is 4. Therefore, we are looking at du over u, and we keep the 2 outside. This is a natural log, so 2 ln u and a constant, and the u must be replaced. And we must keep the absolute value because the expression of 2x plus 3 can be positive or negative, and we are done. Now, what I want to show you is this. What if we had the reciprocal of this number, this expression? Well, we do the factoring, and we get the reciprocal of this one. So we get the integral of 2x plus 3 over 4 times dx. We've seen this before. And now we make up 2 fractions. This one, 2x over 4, half of x, 3 over 4, 3/4. This way, we don't need substitution. X gives you 1/2 x squared times 1/2 is 1/4 x squared. This is 3/4 x, and a constant, no substitution, will do the job here, nice and easy. Want to find an equation of a tangent line to the graph of this function at x equals. We need 2 things. We need a pair, and we need this slope. So let's differentiate to find f prime of x, which is 2x minus 3. The slope would be f prime at 4, which means 2 times 4, 8 minus 3 equals 5. And the pair, it would have coordinates 4 and plug into f of x. So 4 and f of 4. So 4 squared, 16, minus 3 times 4 is minus 12, makes it 4, minus 1 makes it 3. So the pair is 4, 3. And we know the y minus y1 equals m times x minus x sub 1 as the point slope formula. Therefore, y minus 3 equals m5 x minus x sub 1, 4. And I can write this as 5x minus 20 -3 changes to +3, and we are done. By the way, this pair belongs to the original function, also belongs to this tangent line. So if you plug in 4, you must get 3. You do, it does work out. The distance in meters of an object from a starting point is given by s of t equals 2t squared minus 5t plus 4d, where t is time in seconds. What is the average velocity of the object from 2 to 4 seconds? This means total distance over total time. The basic concept of d equals rt. D is the distance, in this case s of t. R is the rate, average speed, and t is the time. So the definition is simply s of t sub 2 minus s of t sub 1 over t sub 2 minus t sub 1 from 4 to 2. You plug in, and that means into this you plug in 4, you plug in 2, you do the math, and you end up with 7. And you write the units, meters per second. So this is elementary. In part B, it's asking for the instantaneous velocity. And the difference is, when they give you 2 points in time, it means average, even if they don't mention it. When they give you 1 point in time, it means instantaneous, and that means differentiation. So you have to differentiate this. So v of t is s prime of t, which makes it 4t minus 5. We want it at 6. We plug in 6. Four times 6 minus 5 is 19 meters per second. Acceleration is the second derivative of the position function. A of t is v prime of t or s double prime of t. So when you differentiate these 2 times, we've already done it once here. If we differentiate it again, we simply get 4. 4 is a constant. If it was not, we would have to plug in 6. Then it doesn't make any difference at which point. It'll always be 4 meters per square second, because A of t is dv dt. Let me just write, I want to make sure you see the units. A of t is the same as dv dt. And the velocity, meters per second. This is per second, so it becomes meters per square second. When does the object reach a velocity of 31? So look at the velocity. Simply put, set it equal to 31 and solve. You move the -5. (36 divided by 4), 9 seconds. We want to use differentials to approximate the square root of 27. So what do we need to do? I'm reminding you that f of x plus delta x is f of x plus delta y. And that's exact. F prime of x is dy dx, dy is f prime of x dx. So over here, if I replace the delta y with dy, it's an approximation. I'm using the differentials to come to the answer. And as you recall, as we go from x to x plus delta x, this is delta x along the x-axis. When it comes to the tangent line or a function, makes no difference. This is delta y along the curve or the function, delta y. But this one is dy along the tangent line. Dy and delta y are different. The smaller the delta x, the closer those two values. Normally dy is easier to calculate. That's why we go that route. So with that being the case, we want two things. One, a function that represents that. All you have to do, read this. What operation are we doing? Square root of 27. So the function f of x is square root of x. Then we want to choose a number closest to 27 that we can easily find the square root, and clearly the answer is 25. So if you choose the number to be 25, then from 25 to 27, there is a difference of positive 2. That is the delta x from 25 to 27. In other words, this is 27 minus 25. But if I want square root of 24, from 25 to 24, we go down by 1, so delta x becomes -1, and that sign is important. So f of x plus delta x is approximated by f of x plus dy, where f of x is square root of x, and to differentiate that, we get 1 over 2 square root of x. I want to remind you how it's done, although by now I think everybody knows this, but this is x to the power of 1/2. So if I want to differentiate that, f prime is 1/2 x to the power of 1/2 minus 1, which makes it x to the power of -1/2, which is 1 over 2 square root of x. And therefore, we are dealing with that. What we are interested in is square root of 27, which means f of 27, which means f of 25 plus 2, which means x is replaced with 25, dx or delta x is replaced with 2. Let's do that. As you know, square root of 25 is 5, therefore this is 5, this is 5, these 2 cancels out, these 2, it's 5 plus 1/5, or 5 and 1/5, or 5.2. All of them mean the same thing. And if you look at the answer you get from a calculator, with of course a lot more decimals. So if you were to round it to only 1 decimal, that 1 will change to 2, become identical. This is how close they are, because number 2, dx or delta x, is fairly small compared to the choice of x, which is 25. And you're done. The second method, which gives you the same answer, would be using linearization, meaning finding the tangent line. And you don't have to memorize that, just a point slope, y minus y1 is m times x minus x of 1. And what that means is I need to find the equation of a tangent line for this function at this point, which means I need a pair and I need the slope. The slope is very simple. Look at this one, f prime of x. So if I plug in 25, right, that gives me 5 here. 1 over 10 is the slope. What about the pair? 25, plug it into the original function. Square root of that is 5. So the pair is 25 comma 5. That's the pair. That's the slope. I'm going to leave it for you to find the equation of a line. And whenever you're done, in order to get to this, replace the x with 27. You can do that. This is the second method. Find the absolute max and mean for the following function. Remember, this is a closed interval theorem. And the method says, find the critical points by finding f prime, setting it equal to 0 and doesn't exist. Find the values that you see here, the endpoints, the critical points, plug in the original function, and find the absolute max and absolute mean. So first and foremost, what type of a function is this? It's a polynomial of degree 4. The domain is all real numbers. That means it's continuous from negative to positive infinity. That makes it continuous in the given interval of -4 to 1. Let's find CPs. That means let's differentiate this. Becomes 4x cubed minus 36x. Let's find f prime of x. Since we want to set this equal to 0, we're going to factor the 4x out. X squared minus 9 can be further factored into x plus 3x minus 3. This gives us x equals 0. This gives us x equals negative 3. This gives us x equals positive 3 if we set them equal to 0. So there are 3 answers. We also have to look at where f prime doesn't exist. F prime doesn't exist, that means what type of a function you have. The domain is all real numbers. It exists everywhere. If it's, for example, a fraction, whatever makes the denominator 0, that would be where f prime doesn't exist. I'm talking about f prime. This one, not f, I'm sorry. So wherever this doesn't exist, this is a polynomial of degree 3. So there are 1, 2, 3 critical points. Let's look at the given domain. Is 0 in between? Yes. Is negative 3 in between? Yes. Is positive 3 in between? No. So we can only use the first two. And that's why I use this symbol 0 and negative 3. It would be an element of, remember, I've gone over that, this interval. So again, I'm going to write it. This means an element of, so it belongs to this, and that works. So you have to plug in. What do you plug in? F of A, which is negative 4. We have 2 critical points, f of negative 3, f of 0, and f of b. See? So plug it in and evaluate it into the original function. We get the following answers, which means the largest value, so we are in the third step. The largest value is 0. Absolute max is 0 at 0, 0. The smallest value is negative 81. So absolute mean is negative 81 at negative 3, negative 81. So it uses the closed interval theorem. We don't want to mix up the various theorems. We want to evaluate the integral. The purpose of that is to remind you of how we deal with definite integrals, where substitution is in order, and here's how we deal with that. First of all, this is a polynomial. This is times 25 minus x squared to the power of 1/2. 25 minus x squared is a polynomial also. And so the choice of u is the more complicated one, which is 25 minus x squared. The u becomes negative 2x dx. And I hope you remember how we deal with this. The easy way, as far as I'm concerned, and I hope you're willing to learn this, I'm going to put the x next to that. And because negative 2 is a number missing, I just throw in negative 2 and I undo it with its reciprocal. You can do that with numbers. It goes a lot faster this way. And so you're dealing with the following. And notice I'm not going to put the limits yet for u because the original limits pertain to the original variable x. I changed the square root of u to the power of 1/2, so I can use the power rule. This number remains. This is 1 over 1/2 plus 1, u to the power of 1/2 plus 1, and 1/2 plus 1, as you see, is 3/2. And 1 over that is 2/3. We want to multiply the 2/3 by negative 1/2, which results in negative 1/3. I still have not written the limits, so I'm going to go back to the original variable, original limits. I can do the math, and I'm done. Or if I put the 3 here, the lower limit gives me 25 minus 9 is 16. If I put the 4 here, the upper limit gives me 25 minus 16 equals 9. And now we evaluate it in this fashion, which means I'm going to put the negative 1/3 out, and then 9 to the power of 3/2 minus 16 to the power of 3/2. I showed you last time, so quickly, this is square root of 9 cubed, 3 cubed, 27. This is square root of 16 cubed 4 cubed 64. Their difference is negative 37 times negative 1/3. So this is negative 37, and times negative 1/3 is positive 37/3. The radius of a blood vessel is 1.4 millimeters. A drug causes the radius to change to 1.3 millimeters, and we want to use differentials to find the approximate change in the area of cross-section of the vessel. First, let's discuss the given, and then we go over how we find this by explaining what we have, what is given, so on and so forth. So we have the radius of the blood vessel, and this is in a circular shape, and that is 1.4. And the drug causes it to go down. So originally, we have this radius R, the big one, and now we have this smaller R, and their difference is dr, this much. It is smaller by this much. So R originally is 1.4, and the new R is 1.3. Therefore, dr is negative 0.1. This one has shrunk. So in other words, 1.3 minus 1.4. And of course, we know the area is pi r squared. We want to use the differential to find the approximate change in the area. So A is pi r squared. We want dA. That's dr. And this is translation of the question. I'm again reminding you of what's the differential. So in this case, we are interested in really finding this part. Take a look at this one. F prime of x is dy dx, dy is f prime of x dx. So we want to find a prime of r, which is dA dr. And then dA is the product of these two. That's what we are looking for. So A is pi r squared. By now we know that dA dr is pi times 2r, or 2 pi r. It's pi which is a number, times r squared gives us 2r, and therefore 2 pi r, and dA therefore becomes 2 pi r dr. So all you have to do, replace the r with the original r, which is 1.4, and dr is negative 0.1 because it's shrinking. And use a calculator. This is, of course, negative 0.28 pi millimeters squared. And if you use a calculator with a bunch of decimals, this is an approximation. Most likely, this is what we want, but it's important to have this. In case they ask you for that, that's fine, but this is more important because it's precise. Now, this is using differentials, but what if we just wanted to use algebra or geometry and find the exact? The exact, simply put, means the shaded region class. So you find the area of the bigger one, you find the area of the smaller one, their difference is the answer, and you have to go with the negative. In other words, the area of the smaller one minus the bigger one, because it has got smaller. So if the question is how much it has shrunk, then the larger minus the smaller. When you say it has shrunk by that much, you are giving the negative sign. So the exact is delta y, or in this case would be delta A, pi r squared. This is 1.3, the small one. and then minus pi r squared again, the larger one is 1.4. I factored out the pi. And as you can see, this is pretty close to what we got here. A farmer with 240 feet of fencing wants to build an E-shaped enclosure besides a creek as seen in the diagram. Find the maximum area that can be enclosed. So the objective is to maximize the area, which is x times y. And the constraint is we have 240 feet of fencing, 1, 2, 3x. Normally plus 2y, but since this side doesn't need it, just plus 1y or simply plus y equals 240. We solve for y in order to replace it here and make a function of one variable. So y is 240 minus 3x when you put it in here becomes a of x equals x times 240 minus 3x. And here's the restriction on x. When you look at this one, first of all, x represents dimensions can't be negative, so it must be positive. Secondly, according to this, if you set this equal to 0, x becomes 80, and then there is no area. So 0 and 80 are not included, so you are dealing with the open interval of 0 to 80. Let's differentiate this. It's easier to distribute and make it 240x minus 3x squared in order to differentiate. So a prime of x becomes 240 minus 6x. We set it equal to 0, and x becomes 40. So this is CP. Is this going to maximize or minimize? We don't know yet. However, what we do know, because it's an open interval, and because there's only one critical point, whatever we decide, it's not only a local, it's also an absolute max or mean. Okay, so an easy way, find a double prime, which is negative 6, and it becomes a maximum. Why is that? Because when second derivative is negative, it means it's concave down. Looks like this. So if x equals 40, you can go back to this or this equation and find the y. 240 minus 3 times 40 makes it 120 feet. So the dimensions are 40 by 120, and therefore the area is the product of the two, which is 4,800 square feet. I want to remind you of one more question we have done in the past. A bacterial colony has a population of a P of t equals 20t over 10 plus t squared. In millions, t hours after a nutrient is introduced, use differentials to approximate the change from t equals t2 to 2.4. And the same concept as it was previously, as far as the differential is concerned. The original t is 2, and we go up by 0.4. That means dt or delta t is 2.4 minus 2, or 0.4 hours. So what we need to do, given p of t, we have to find a p prime of t, which is dp dt, and then we find dp. That is the process that is involved. And to find a p prime of t, we use the quotient rule, f prime g. So if you call this f, if you call this g, it's f prime g minus g prime f over g squared, which means the top gives you 20 times the bottom, 10 plus t squared, minus the bottom gives you 2t times the top 20t, and you put the denominator squared. That is dp dt. You're going to distribute. 200 plus 20t squared minus 40t squared. You can combine the two. This is your dp dt, therefore dp is the same thing times dt. And you know, if you want to evaluate it, you're going to replace the t with 2 and dt with 0.4. We are going to do that. This is 4 times 20 is 80. 200 minus that is 120. And this is 4. So 14 squared. 196. So divide 120 by 14 squared times 0.4. We get 0.245. We put the units. Now, the exact amount is delta P, or P of a 2.4 minus P of 2, 0.189. By the way, everybody knows this means 245,000 and this means 189,000. The reason, again, I've explained it before, there is some sort of a discrepancy, and there should be, by the way. It's pretty large because 0.4 compared to 2 is fairly large.